viewers, you are welcome to another session of Supreme Success tutorial. And today we shall be taking you through isomerism. And isomerism is a very important topic as far as organic chemistry is concerned. It is primarily geared towards helping you to understand how compounds can have a change of structure despite possessing the same molecular formula. So isomerism is a topic that is usually tested by most of the examining bodies that prepare. IJMB, WAEC, JAMB, NECO, and it is very essential that we take note of the core areas. So what are the things we shall be discussing under isomerism? We'll be looking at the definition of isomerism. We shall be looking at first the definition of isomerism. Then we look at classification, or what we refer to as types of isomerism. And we will be looking at importance, significance of isomers in chemistry, definitions of isomerism, but common mistakes, common errors that candidates make while attempting questions under isomerism is that many are unable to differentiate between isomerism and isomers. Many are unable to differentiate between isomerism and isomers. So, as candidates preparing for exams, you must take note of differences between isomerism and isomers. When you are asked to define isomerism, do not define isomers. And when you are asked to define isomers, you should not define isomerism. So what is the difference? Isomerism is a phenomenon whereby two or more chemical compounds have the same molecular formula but different structural formula, but different structural arrangement of atoms. We can look at this compound. This is C5H12. C5H12 is a compound referred to as pentane. C5H12 is pentane. However, this compound, this molecular formula of C5H12 can represent a number of other compounds. So we say isomerism is a phenomenon whereby compounds have the same molecular formula, but what? Different structural formula. Some textbooks will describe it as having different structural arrangements of atoms. So isomerism is a phenomenon whereby two or more chemical compounds, we have C Now this chain format of pentane. We can see how many carbons do we have here? 1, 2, 3, 4, 5. And how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is a straight chain formula for a compound that has 5 carbon. However, this compound with 5 carbon and 12 hydrogen can also have different structures. An example of such kind of compound is this, where we have 4 carbon on a straight chain So looking at this is pentane with 5 carbon and 12 hydrogen on the straight chain. Then this is methyl butane. So we have pentane and methyl butane. Both of them are isomers in the sense that they both have 5 carbons and 12 hydrogen. So the same molecular formula. That is MF. But what is different? Structural formula. So this phenomenon whereby 2 compounds have the same molecular formula but different structural formula is referred to as isomerism. Take note of the keyword phenomenon. So isomerism is a phenomenon whereby 2 or more chemical compounds have the same molecular formula but different structural formula. Of course, the effect of the structural formula is that the compounds will have different names. So that is the reason why pentane and methylbutane have different names, despite the fact that they both possess 5 carbons and 12 hydrogen. Yes, then after defining isomerism, so what are now isomers? Pentane and methylbutane are isomers. That means these 2 compounds, pentane and methylbutane, they are isomers. But the phenomenon, the process, the reason why they have the same molecular formula and different structural formula is what we refer to as isomerism. So the reason is, so isomerism is the phenomenon, while isomers are the compound. So isomerism is the phenomenon whereby 2 or more chemical compounds have the same molecular formula but different structural arrangement of atoms. Now, there are different reasons why the structural arrangement of atoms can differ. 1, it can be due to a difference in the spatial arrangement. And when there's a difference in the spatial arrangement, we say such a type of isomerism is referred to as geometrical. It's referred to as stereo isomerism. So when there's a difference in the spatial arrangement of atoms, we call it stereo isomerism. And when it is just due to a difference in the normal arrangement of atoms, they are referred to as structural isomerism. So that takes us to the next part of this topic, classification of isomers. Okay, classification of isomers. So isomers can be classified, can define of isomerism, that is the phenomenon. It can be classified into two. We have the structural isomerism, and we have the stereo isomerism. Isomerism can be broadly divided into two. Structural isomerism, due to difference in the structural arrangement of atoms. While stereoisomerism, due to a difference in the spatial arrangement of atoms. So there can either be a difference in the structural arrangement of atoms, that is what we call structural isomerism, or there's a difference in the spatial arrangement of atoms, we call it stereoisomerism. Structural isomerism can now be subdivided into four. We have into five. We have five of them. Structural isomerism into five. We have the chain or positional isomerism. We also have the tautomerism. We also have functional group isomerism, which is due to a difference in the functional group. We also have positional isomerism. Then we have metamerism. Like I stated, isomerism can be classified into two. We have those that are due to the difference in the structural arrangement of atoms. We have stereoisomerism, those that are due to a difference in the spatial arrangement of atoms. The word spatial comes from space. So there are so chain or positional isomerism. What is happening in chain or positional isomerism? It is due to a difference in the chain length. Look at this. This has a chain length of 4 carbon, because there are how many carbon? 1, 2, 3, 4. And if I want to look at this is H. This compound is referred to as butane. Butane has 4 carbon. Why? I will be using the condensed format. This is 2-methyl-propane. Looking at butane and 2-methyl-propane, we realize that they have the same number of carbon atoms. But looking at the chain of this is 1, 2, 3, 4. This chain has 4 carbon. While this chain, looking at this line, let's look at this line, this line has 3 carbons. So the chain length of the first is 4, the chain length of the second is 3. So there has been a difference in the chain length. So that is why it is called chain isomerism. It's called chain. Okay, it's chain or branch isomerism. Chain or branch isomerism. And why is there a difference in the chain length? It is because there has been a branch. This thing is no longer moving straight. Before it got to the 4 carbon, it has branched. So chain or branch isomerism is due to a difference in the chain length of the compound. Then the next type of isomerism we are talking about here is tautomerism. Tautomerism is common in compounds that have multiple bonds. You can see it in a compound like ethanol. You can see it in a compound like ethanol. This is ethanol. There's a dynamic equilibrium. So you have C. Remember that when you are drawing organic compounds, the number of bonds surrounding your carbon should not be more than 4. That is because carbon is invariably tetravalent. It must always have a valency of 4 carbon. 1, 2, 3, 4. 1, 2, 3, 4. So this is ethanol, and this is ethanol. So the process whereby ethanol is converted to ethanol and they exist in dynamic equilibrium with each other is referred to as tautomerism. So tautomerism is a phenomenon whereby two compounds exist in dynamic equilibrium with each other as a result of a simultaneous shift. What do we mean by simultaneous shift? In a proton and a double bond. If we can look at this, this is hydrogen. There has been a shift of this hydrogen to this place. And hydrogen is usually referred to as you can see, this is H. For better illustration, you can see here. You can see the arrows here, they are half arrows. So we say there is a simultaneous shift in a double bond. This double bond will move to this place. So I'm going to be having C, double bond C. That means this double bond has moved from this position to this place. Then I have hydrogen. I have hydrogen. Now this hydrogen here is called a proton. Usually in chemistry we refer to as hydrogen as a proton. So there is a shift of this proton. So where is this proton coming? Remember, you have C and O, and now there is a shift from here to this place. So we now have O with an H, then you have H. There is a simultaneous shift of a double bond. This double bond moves from this position to this place. That's why we now have a carbon-carbon double bond. This hydrogen here moves from its position to the hydrogen, as we can see here. When we have these two compounds that are readily interconvertible, we refer to them as tautomers. Remember that tautomerism and tautomers are just synonymous to isomerism and isomers. Isomerism is the phenomenon. Tautomerism is also the phenomenon. Isomerism is the phenomenon whereby two or more compounds have the same molecular formula but different structural formula, while